Greetings, class. I'd like to talk to you about confidence intervals from Chapter 6, Section 1. I did want to draw your attention to page 299 in your e-text. There's a study tip about common levels of confidence. For example, 90%, 95%, 99%. And they give you a Z value, what they refer to as a critical value for Z, or Z sub C, that you would find for each one of those levels of confidence. Now, you can find these values of Z by using Statcrunch, much like we've done in sections 5.2 and 5.3. If you look at their diagram for a particular value of C, for example, if C is 90%, then we want 90% of the area underneath that normal or standard normal curve here. But we want it between two Z values. Now those Z values, because of symmetry, have the same numerical value or absolute value, but one is positive and one is negative. And when we look at Z sub C, we're concerned with the one that's positive, but we need the area between those two values of C. So if you want to use Statcrunch just to verify a couple of these and get ready for your homework, we can do that. So I'm going to move the screen over here so that we can see Statcrunch and how we did this last time. So in Chapter 5, you went Stat, Calculators, and Normal. We use the Normal calculator. Now the difference is we don't want to the left side, we want between. So you have to click the Between tab. We're looking for critical values of Z, so the standard, the mean has to be 0 and the standard deviation is 1. The area, or the portion of the curve that we want for C equal 90% was 0.9. And when I click compute, it says that my values run from negative 1.6449 to a positive 1.6449. If you round that to 3 decimal values, you get 1.645. And that's the same Z value they have over here, the critical value of Z, when C is 90%. So I'd like to go ahead and work through a couple of problems in your text. I'm going to go to the exercises at the end of section 1. And we'll work a couple of these that are somewhat similar to what you'll see on your homework. So let's look at question 6 from your homework. I'll scoot this over just a little bit further so you can see the instructions. It says, find the critical value Z sub C necessary to construct a confidence interval at the level of confidence C. So for number 6, our C value is 0.85. So I'm going to close my calculator out, and I'm going to start over so you see where we go, just like in 5.1, 2, and 3. Stat, Calculators, and then Normal. It is a standard, we're looking for Z values, so it's a standard normal curve where the mean is 0 and the standard deviation is 1. However, I don't want to the left or the right. I don't want that. I want the between value. And the area under the curve that corresponds to this C equal 0.85 is 0.85. That would be the same as a confidence level of 85%. So the Z value that we're concerned with would be 1.4395. And if you rounded it to, say, 2 decimal places, that would be 1.44. Much like what you would get if you were looking on a Z table. But it's just a little easier to use your normal calculator from Statcrunch. Now I'd like to look at another problem further in the homework. It's like the next set, and they want you to match the level of confidence with its representation on the number line. Now, they're not telling you everything when you look here in the book, but if you click on the problem, and wait a minute because it takes a while, and we go to exercise 17, they're going to give you some extra information here that you don't see in the text itself, which is kind of strange that they wouldn't have included it. And so if you look at this problem, it'll say match the level of confidence C equal 0.88 with its representation on the number line given that X bar, the mean, is 57.4, the standard deviation is 7.8, and N is 65. So we can use the normal calculator. We have a sample size that's bigger than 30. We know the standard deviation of the population, so I can find the interval that matches this. Now, in order to do this, you need to use a different it's not a calculator, it's actually Z-Stats. So you go to Stats, and you go to Z-Stats, and one sample with a summary. So we have a one sample Z summary. The sample mean is 57.4. The standard deviation for the population was 7.8. And the sample size again is 65. Now, we're not doing a hypothesis test. That's for Chapter 7. We are doing a confidence interval, and the level is C equals 0.88 or 88%. I'm actually going to store it in a data table and click compute. And then I'll close that option window. And you can see here that the lower limit is 55.8958, or basically 55.9. And the upper limit is 58.9. So if we come over here and look at our options, we know it's going to run from 55.9 to 58.9, and our mean was 57.4. So this would be answer B. And I used the Z-Stats. It's a different kind of test that we're running in order to find that confidence interval. So the left side will be your lower limit, 55.9, and the upper limit is the right-hand end point for that interval, 58.9. So I'm going to close that out and close that window. And let's look at some more of these that'll be run the same way. For example, let's look at 22. It says C is 0.95. The sample mean is 31.39. The population standard deviation is 0.8, and N is 82. So once again, N is greater than 30, so the central limit theorem says that our sampling distribution will be normal, so we can use z-scores. And we know the standard deviation. Those things are what we have to know to be able to do this. So going back to Statcrunch, remember where we went? We went Stat, Z-Stats, one sample with a summary. The sample mean from number 22 was 31.39. The standard deviation, oh wait, I was on 23, I'm so sorry. The sample mean was 10.5. I apologize for that. So 10.5. The standard deviation was 2.14, and the sample size was 45. We're doing a confidence interval, and the level of confidence that we're looking at is C equals 0.99. I'm going to store it in the data table and compute. And so if we look at this a little more closely, I can see my lower limit is 9.678 or 9.68, and my upper limit is 11.32. So based on this 99%, for question 23, I'm 99% confident that the true population mean would lie between 9.68 and 11.32. If you had to write the confidence interval, you'd actually write it with parentheses, 9.68, comma, 11.32, and close the parentheses. So you'd see something, I'm going to enlarge that a little bit so you can see. You would see something that looked like, and it's interval notation. The lower boundary is 9.68, the upper boundary is 11.32. So when you do these in my stat lab, they're going to give you a box for the lower limit, and they're going to give you a box to type in the upper limit. All right. So let's see. I'm going to pause for a minute and come back. So now I'd like to look at problem number 36, sodium chloride concentration. In 36 randomly selected seawater samples, the mean sodium chloride concentration was 23 cubic centimeters per cubic meter. Assume the population standard deviation is 6.7 cubic centimeters per cubic meter. We're to find a confidence interval for a 90% confidence and 95% confidence level. We're going to interpret the results and compare the widths of the two intervals. We're definitely going to use technology. Now we're able to do z-stats because our sample size is 36, so that's more than 30. And we know the population standard deviation. So those two things allow us to do z-stats. So we're going to go stat, z-stats, one sample with summary. The sample mean was 23 cubic centimeters per cubic meter, so that's 23. The standard deviation it says to assume is 6.7. And the sample size, they took 36 seawater samples. I want to do a confidence level, and the first one I want to do is a 90%. So it's 0.90 confidence interval. I'm going to store it in the data table and compute. Then I'm going to close that out. Get this over a little bit so you can see the lower limit. So the lower limit's 21.16 and the upper limit is 24.84 if you round it to 2 decimal places. So what that means is that I am 90% confident that the true population mean is between 21.16 and 24.84. Now, if I want to increase my confidence to 95%, I redo the calculation, stat, z-stat, one sample with summary. The sample mean is exactly what it was before, 23. The standard deviation is still 6.7. I took 36 samples. And again, we're doing a confidence interval, but this time not 95, it is 95, I'm sorry, 0.95. I'm going to store it in the data table and compute. And you can see that it moved this over just a little bit. And this is my 95% confidence interval. And the lower limit is 20.81 and the upper limit is 25.04. 0.19 if you round that to 2 decimal places. So if we compare these, let's see if I can get this to go back.